Hey everybody, welcome back. This is Professor L, and in this segment, we are going to do a little bit more work in our studio. Specifically, we're going to go through the very first module of the R Programming E SWIRL lessons. So at this point in the game, it's important that you have R installed on your machine. You got R Studio, the IDE, installed sitting on top of that. That's really what you're going to open. You're not even going to open R. You're just going to open R Studio to get here. So take a look at the previous segments to see how to do that. And you will need to have already installed the SWIRL lessons that are appropriate for following up in this particular video. So if you need to do that, take a look at the previous segment, which was focused on how to install those lessons. And what we're going to do today, as I already mentioned, and I don't want to be too redundant, is we're going to go through the very first of the 15 modules in the R Programming E set of lessons. So the first thing we're going to do here is recognize that I do have my R script file opened up in this text editor in the top left corner. As we go through the steps in the SWIRL lesson in this first module, I'm going to keep track of every step by putting the input that SWIRL asks me for in line in this document. So by the end of the lesson, every line of this script file will have the line of input that I had to put into SWIRL to make it to the next step in the lesson. Okay, so if we want to, we can make, again, a little comment at the top here. Let's call this SWIRL R Programming E Module 1, since that's what it is. If you want to get a little decorative here with your commenting, you can. There we go. So we are going to go through the first SWIRL module, and in order to do that, remember, we already downloaded the package, so it's already on our machine. What we're going to need to do next is load the library. So let's go ahead and load that SWIRL library by using the library function. And we are going to feed it the name of that package that we want to reference, SWIRL, which we've already installed. So it's always good, again, to comment your code. So we know what's going on here. And I'm going to go ahead and run that line of code, Control-Enter or Command-Enter on the Mac to do that. And we can see now down in the terminal window, we are ready to begin. So I'm not going to keep track of every step just yet, okay? But it tells me to type SWIRL when I'm ready to begin. So what we're really going to do as we go through the lesson is literally the following. Anytime I have to put input down here, okay, the alternative way of entering that is I could have written it up top in the script file, and then I can run that line directly from the script file if I want to by pressing Control-Enter, and it will do that real quick, copy-paste down into the console, and we'll run that command here. So I ran that line. That opens the SWIRL lessons. So we loaded the package, then we opened the lesson, and now again it's asking me for my name, so I will give it my name. And again, it goes over some instructions. So every time that I see these instructions here, I'm going to read them carefully, right? We're going to follow directions very carefully. And anytime, again, I see these three dots, okay, that is always your cue to press enter to keep on moving. So down there in the console, you can see my cursor blinking. I hit enter. Asks me for a selection. So we went through these couple steps in the last segment. So pick one. Okay, and again, it gives me some instructions here. So please take your time and carefully read these instructions. You can pause the video if you need to. Okay, and also be aware of these commands that can help you in instances where you want to leave R or leave the SWIRL assignments rather, or do anything else. So we are going to get started here. Again, anytime I see those three dots, I'm hitting enter. And now it asks me for the course that I want to choose. And the one that we are specifically going to be working on is the R Programming E course, which is choice number 3. And it's important that you loaded the right course. If you don't have the E at the end of it, then you're not going to be able to submit properly what we need to submit for that part of the course grade, okay, if that's relevant for you. So I'm going to load up the R Programming E module here, or rather lesson. It's the set of lessons. And now I can see the 15 different modules here. And next, we're going to go through the first one here. We're going to go through the basic building blocks module together, make sure we can see how that works and what's going to happen at the end when it's time to submit it. Okay, all while we're going through, remember we are going to use our text editor up in the top left, our R script, to keep track of every move that we make. So let's go ahead, clear these drawings here, and we are going to begin lesson number 1, building blocks. So again, some instructions. I'm going to read those instructions carefully. In this lesson, we're going to explore basic building blocks of the R programming language, and I'm going to keep an eye on the status bar here. Right now, you'll notice it's at 0%. Again, that thing will start to fill up as we hit enter and move on to the next step, helping us gauge how far we are in the lesson. So right away, I hit enter here, and you see already we're at 3%. Hey, if at any point you would like more information, you can use this help start function in the prompt when you see that little arrow in the bottom left. But again, anytime we see those 3 dots, we are hitting enter to move on to the next step after we carefully read that information. Okay? So you'll notice now we have that little greater than sign in the bottom there. That is the prompt symbol. R is asking us for some input there. And we're going to read again that question carefully. So it says in its simplest form down at the bottom here in red, R can be used as an interactive calculator. Type 5 plus 7 and press enter. So here's what we're going to do. It's asking me to type 5 plus 7 and press enter. So I could do that up here, hit control enter, and it's going to copy, paste that down into the bottom. Okay, or I could literally type 5 plus 7, and you'll notice it looks like there's a space between it there. Doesn't really matter. R is at least smart enough to figure out the arithmetic that you're doing here. So again, anytime I have to put input down in the console, what I'm going to do is I'm going to keep track of that input above in the text editor, in that R script file. So I hit enter here. Great job, it says. R simply prints the result of 12 by default. However, R is a programming language, and often the reason we use a programming language as opposed to a calculator is to automate some processes or avoid unnecessary repetition. In this case, we want to use the result from above in a second calculation instead of retyping 5 plus 7 every time. So what we're going to do next is we're going to create a new variable that stores that result. Okay, and we're 11% done with the lesson. Oh, now we're 13. Okay, the way you assign a value to a variable in R is by using the assignment operator. We're going to use the assignment operator, and that is a less than symbol followed by a minus sign. This is the assignment operator right here. A less than symbol followed by a minus sign. It looks like a leftward pointing arrow. Okay, we talked a little bit about that in the last segment. Let's just think of the assignment operator as an arrow. Okay, that's what I said. You are assigning the value on the right side of the arrow to the variable name on the left side of the arrow. So it says to assign the result of 5 plus 7 to a new variable called x, you type x assignment operator 5 plus 7. Right? And this can be read as x gets 5 plus 7, or x is assigned the value of 5 plus 7. Okay, so you'll notice they even told us what to type here, which is pretty nice. So I can just actually copy that, put it above in my script file, okay, and then I can enter it below. And it tells me again, great jobs, right? Really good pat on the back, makes you feel good when you see that. If I didn't put in the right input, okay, it would give me another message. And I'll show you in a moment what happens if you make a mistake. Not too harsh, but it does guide you back to the correct answer. So again, you should notice here that R did not print the result of 12 this time. Right? We just see that it assigned a value to a variable. And the other thing we should notice is that in the top right corner of our screen in the global environment, we can see, hey, here's X, a new variable we've created, and here is the value that's been assigned to it. Okay. Now, let's go ahead. We see those dots, enter, time to move on, and we're about a quarter of the way through the lesson. Now it says to evaluate, to view the contents of the variable X, just type X and press enter. Now suppose I make a wrong choice here. I put Y or something. Oh, object Y not found. Gotta type X and press enter. What happens if I just put 12? Not quite right. That was the right value, but R knows that's not what it wants. So let me actually do it properly. Let me put X here, enter, and now it is giving us that nice pat on the back. That is correct. So next it asks us, let's go ahead and store the result of X minus 3 in a new variable called Y. And they don't tell us how to do that here, but we should think of how to do that, right? Y, what do I want to store in it? Well, I want to store X minus 3. Okay, I think that is what we want here. And you'll notice I'm not commenting every line now in the lesson. In fact, we can write that. Put a little comment in there. Lesson starts here. And you don't need to comment every line there within the lesson. I know it's associated with the lesson. I know what to look for there. But it is important that you are tracking all of your input here. So again, I got Y. I'm assigning to it X minus 3. Boom, boom. And we are 30% through the lesson approximately. And now it wants me to report the value of Y. In fact, I should have wrote that up here when I reported the value of X. So again, any input, Y is going in down there, Y goes in up in the script as well. Okay, and again, we are doing just so well. Excellent. We're about a third of the way through the lesson. So now it tells us we're going to do something. We're going to create a small collection of numbers called a vector. A vector is a set of coordinates. Could be two-dimensional if there's two coordinates, X and Y. Could be three-dimensional if there's three coordinates, X, Y, and Z. And any object that contains data is called a data structure, and numeric vectors are the simplest type of data structure in R. Okay? In fact, even a single number is considered a vector. We call them scalars, really, but it's technically a vector with only one coordinate, only one dimension. So we're going to learn how to build a vector. Now, the easiest way to create a vector is with this C function, which stands for concatenate or combine. And we're going to create a vector containing the numbers 1.19 and 3.14. And we're going to do that, and it tells us exactly how to do it here. We're going to type this exactly. C, and we're going to feed the C function 3 arguments. We're feeding it the 3 values separated by commas. Okay. So I put it up in my text editor. I put it down here, and I run it. Now, before I run it, actually, I got to read the directions carefully, right? I don't want to make that faux pas. Do as I say, and I do. So before I run it, it tells us try it now and store the result in a variable called Z. So before I run it, if I did run it and I forgot to do that, okay, not exactly, give it another go. And it literally tells me what I need to do to progress farther. So that wasn't exactly the right input. I needed to assign that vector to a variable called Z. So again, I'll fix that up on line 14 in the script file, and I will fix that down here in the input of the console window. And boom, we are really on a roll. And we're 37% done with the lesson. So anytime you have questions about a particular function, you can access R's built-in help files via the question mark command. So I talked a little bit about the help files and the help viewer last time. If you recall, the help viewer was this window in the bottom right if you were to click on the help tab. Okay, and what we're going to do now is we're going to change that help tab, rather to pull up the documentation for the help command associated with the C function. If I wanted to know what does that C function do, okay, we can type question mark C without the parentheses. I think even if you included the parentheses, it would be okay. I think R would still actually run it. And this will pull up documentation in the bottom right corner associated with this function when I run that. Okay, so now I can see here in the help window, oh, this function here, C, is part of the base package in R. It's not part of any special package you have to add. And it allows us to combine values into vectors or lists. Okay, and it gives you a description of the function, some examples of usage, tells you what the arguments are, what all the things you can plug into the function are, and some more details as well as some examples of how to use the function. Okay, so the help can be very, very useful. Again, it's super important when you're doing analytics that you are flexible about troubleshooting issues on your own, looking up the help documentation, Googling. If you get an error that you don't understand, you should Google that first before you start emailing faculty, bothering them, asking them about something that you probably could have looked up in 5 seconds. So again, those hacking skills, being independently capable of trying to look up new things or circumventing obstacles as you find them, and really implementing it with trial and error is a really important part of analytics. It can be frustrating at times, but it's very important skill for you to acquire, being able to troubleshoot and problem solve independently without always having to consult an external resource. So let us keep moving on here. We can see how to get this help documentation. And now it's asking us to type Z to view its contents. So that's not too bad there. We are going to view Z. And when we view the contents, okay, it gives us the output in that terminal window. And it also says, hey, notice there are no commas separating the values in the output, right? We had to put commas in between them up top in the console window when I defined what Z was. Those commas separated the values, but it just returns the vector without commas in it. That is how R displays a three-dimensional vector. Those are the 3 coordinates. You can combine vectors to make a new vector. And let's create a new vector that contains Z, 5, 5, 5, and then Z again in that order. And it says, don't assign this vector to a new variable so that we can just see the result immediately. So I want to make a vector. We're going to use this concatenate function. And now I want Z followed by 5, 5, 5, followed by Z again. Okay, now you should remember Z has 3 elements. So I'm going to have the 3 elements of Z, then 5, 5, 5, followed by the 3 elements of Z. So you should think about how many coordinates or elements would be in that vector. It looks like there's 3, but remember, Z also has coordinates within it. Okay, so when we run that line, here is what we see, no pun intended. Right? Here is Z, those 3 values, 1, 2, 3. Here's our 5, 5, 5 in the middle, and here is Z again, for a total of 6 coordinates here. This is a 6-dimensional vector. And again, they give us this very nice pat on the back. All that practice is paying off. Good job, and we are about halfway done here. Numeric vectors can be used in arithmetic expressions. Type the following to see what happens. So again, they're telling us exactly what to type here. We're taking Z times 2 plus 100, but Z wasn't one number. It was a series of 3 elements. What is that going to do? Well, let's take a look. Okay. The result of this calculation still is 3 elements. Okay, we can see that right here. Okay. Now, what did it do literally to every element? Well, it first multiplied those elements by 2. So instead of 1.1 there, we got 2.2. And then we added 100 to it to give us 102.2 in that first element of that calculation. Okay, so what happened here is being explained down here in these directions very carefully, right? First, R multiplied each of the 3 elements by 2, and then it added 100 to each of the 3 elements. So what we've done here is essentially we've automated a calculation. Instead of having to write that calculation out 3 times, we did the same calculation at 3 different numbers, boom, at once. Okay. Very important to be able to display and convey information using vectors and matrices, or matrices in the future. We're going to use matrix or matrices, and that's really important in big data applications as well. Now, moving along, okay, I see those 3 dots here in the bottom left corner, so that is our sign to press enter. The other common arithmetic operators are the plus, minus, divide. The caret is raising something to a power, right? X caret 2 means x squared. And if you want to take the square root, you could raise something to the 1/2 power, if you remember that. But you could also use the square root function, SQRT open close, where I stick the number inside the parentheses that I want to take the square root of. And the ABS function lets you calculate the absolute value. So there are a lot of predefined functions in R. Again, anytime you want to pull up the help documentation for those functions, you can do what we did up here in line 15. I put the question mark before the name of the function without the parentheses, and I run the line of code. And what that did is it pulled up that documentation in the bottom right help window of our Studio console. So again, 3 dots in the bottom, enter, we are moving on. Okay, now it wants us to take the square root of z minus 1 and assign it to a new variable called my square root. So let's do that. So you'll notice you don't just need variables that are 1 letter. You can name variables anything you want. They can be pretty complicated. So we're taking a variable, we're calling it my underscore SQRT for square root. We're going to assign to it the value of z minus 1 after we take the square root of that. So think about what's going to happen now. Z was a vector. Okay, so the minus 1, we're going to subtract 1 from each element, and then we're going to take the square root of the result. That is what is going to happen here. So let's go ahead and run that down in the console. Boom. Okay, that's the answer I was looking for. Awesome. And we're 55% done. Before we view the contents of the my square root variable, what do you think it contains? Well, we said it's going to still contain that vector of length 3. It's going to have those 3 elements. It did not combine those 3 elements together. It's working element-wise at doing that calculation. All right, so let's check if we are correct with our presumption of number 1. And we are. We're on a roll. Now it asks us to print the contents of my square root. And there we have it. We took z, we subtracted 1 from each of these 3 elements, and then we took the square root of the result. So your dedication is inspiring. We've made it pretty far, 61%. And again, we can see the following explanation right here of what just transpired. So moving along 3 dots, I'm hitting enter. Now I'll create a new variable called myDiv. Okay, that gets the value of z divided by my square root. So let's do that. My underscore div. And we are assigning to that the value of z divided by my underscore square root. That's what we want to do here. So let's do that. Let's run it and see how we did. Okay, and we are quite good, and we're also friends. Which statement do you think is true here? Okay, so if you need to take a moment to read that, pause the video. You can go ahead and do that. So remember now, this is tricky because z is a vector, and my square root is also a vector with the same number of elements. So it may not be clear what's going to happen here. It may not be clear what's going to happen here. We might think, oh, my div might be undefined. Okay? But what I think actually winds up happening here is it's going to do an element by element calculation. It's going to take the first coordinate of z and divide it by the first coordinate of my div, the second coordinate of z by the second coordinate, of my square root, and the third coordinate of z divided by the third coordinate of my square root. So let's check and verify. It looks like that is what it does. So let's go ahead and print that value now. That's what it's asking us to do here in the next step. So my div, what is that? Boom. it is a three-dimensional vector. So it was a coordinate-wise division that was done there. Okay, when given two vectors of the same length, R simply performs the specified operation, right? Element by element. That is the key here. Element by element. If the vectors are of different lengths, R will recycle the shorter vector until it is the same length as the longer vector. So normally in math, you cannot add or you cannot do arithmetic operations on two vectors that are not from the same dimensional space, that don't have the same number of elements. But R gets around this problem by reusing the shorter vector in multiples until it has the same length, same dimensions, and then it does that element-wise computations. The next example is going to show us that. Okay. When we did z times 2 plus 100, right, z was a vector of length 3, but technically 2 and 100 are each vectors of length 1, right? 2 is a scalar, 100 is a scalar. Okay, so behind the scenes, R is recycling the 2 to make a vector of 2's, and it's recycling the 100 to make a vector of 100, right? In other words, when you are computing this thing here, z times 2 plus 100, what R is actually doing under the hood is it is doing the following. Okay, it's making a three-dimensional vector of 2's and a three-dimensional vector of 100's, and it's doing that element-wise computation. Okay, that's what's happening in the background. So if you were to do that in the blue box there, you were to do that calculation, you would get the same result as the vector z times 2 plus 100. Now, again, I see those dots. Let's go ahead, move forward here, and look at an example of how R actually does this. Okay, so let's try adding this vector, 1, 2, 3, 4, and the vector 0, 10. So we want 1, 2, 3, 4 plus the vector 0, 10. And you'll notice I'm putting spaces between things up there. I just do that because I think it's a cleaner style of code, but you don't need the spaces. R will skip over those just like it skips over comments as well after it sees that pound sign in the green text. So we want to add these two vectors. Normally, mathematically, this is undefined. It's impossible because you cannot add something with 2 dimensions to something with 4 dimensions. But R lets us do this. Okay, so let's take a look at the result. 1, 12, 3, 14. So we have a 4-dimensional vector as the result, which matches the dimensionality of the longer one here. That first vector was also 4 dimensions. Okay, so let's look at what it did. Okay. The 1 and the 12, I'm going to argue that came from the 1 plus the 1 and the 2 here, and then we added them element-wise. 1 plus 0 is what gives us this 1 down here. 2 plus 10 is what gives us this 12 down here. Okay. Now, what about the 3 and the 14? Well, same thing. Okay, 3 plus 0 is this 3. We added them element-wise, but we recycled the second vector. And then 4 plus 10 gives us the 14 down here. So what we really did is we added the following vector. We added this. We really did, let me write this out, plus C 0, 10, 0, 10. That's really what we did here. R did that automatically for us when it saw that the original vector with 0, 10 wasn't long enough to actually do that calculation in a way it's mathematically defined. Okay. So again, if the length of the shorter vector now does not divide evenly into the length of the longer vector, R will simply still apply the recycling method, but it'll chop off and throw you a warning to let you know something fishy might be going on. But it won't give you an error, just a warning. Okay. So let's take a look at this calculation here. Okay. Taking a 4-dimensional vector plus a 3-dimensional vector now. So again, I'm going to put it upstairs in the script file, and I'm going to run that code, see what happens. Okay. And note that R definitely did not like this, gave us a warning message. Longer object is not a multiple of shorter object length. Okay. Despite that, it did return a vector above. Okay. It did return a vector above. So you got to think about now, well, what did it do? Okay, 1 plus 0 is 1. So it still did element-wise. 1 plus 0 gives us this 1 here. Okay. 2 plus 10 gave us this 12. And 3 plus 100 gives us this 103. So where did this 4 come from at the end? Well, the 4 comes from this 4 here plus the first 0 recycled again. Okay, so it just recycles the first one and chops off the remaining 2 when it's not the correct multiple of the longer vector. That's what happened here. That's how R dealt with that. Okay, so again, what we really did here is the following. Okay, we did plus, instead of this vector, we did plus 0, 10, 100, and then we recycled the 0 again. That is actually what wound up happening. Instead of us actually adding a 3-dimensional vector, which is mathematically an illegal move. You cannot combine this 3-dimensional vector with a 4-dimensional vector by addition. You can't do it. So how does R get around that? It recycles the values to match the dimensionality of the longer vector. This is not an issue we're going to wind up having to deal with a lot in this course, but sometimes it can be exploited to help automate certain types of calculations. Now, again, we are quite good. Pat on the back. Okay. And before concluding this lesson, I'd like to show you a couple of time-saving tricks. So let's see those tricks. Earlier in the lesson, we computed z times 2 plus 100. Let's pretend that we made a mistake and we meant to add 1,000 instead of 100. You could retype the expression, or if you just press the up arrow, it'll cycle through all of the previous commands in our history. Now, you guys remember where the history was? A history of your commands shows up in the top right window here if you click this history tab. These are all the commands that we made. So if you forget or you forgot to do the script file and you need to reference them, they are there. They should be, unless you hit this broom, which clears everything. Okay. Now, another way I can see my history line by line is I can move back down to the bottom left console window and I can hit the up arrow. And you'll notice when I do that, it brings up the last calculation we just did on line 24. If I hit up again, that's the calculation from line 23 above in the script file. If I hit up again, oh, line 22, line 21, line 20, right? We can keep going. And there is the old calculation that we did. But now, if we wanted to fix it, let's change it to 1,000. And we can do that. Let's change it to 1,000. It's asking me for more input, so let's make sure I keep track of that here. And I run it. And boom, keep up the great work. Okay, 95% done. Finally, let's pretend you'd like to view the contents of a variable that you created earlier, but you can't seem to remember if you named it my_div or my_div with a capital D and no underscore. You could try to see which one works, or you can start typing the first 2 letters of the variable name. Okay, then hit the tab key. And sometimes this happens automatically when you're coding. Okay, like if I do this up top in the script file, my_, and it starts to recognize what variable that I've already created that I would like to reference. Okay, so it wants again me to input my div here. So let's put that in, hit enter, and awesome, we are amazing. Now, here is where things are important to follow directions. So we're 100% done with the lesson. Question is, would you like to inform someone about your successful completion of this lesson via email? Answer here is yes. So I'm going to hit 1 for yes. Asks me for my full name. So you'll put your full name here. Okay, what is the email address of the person you'd like to notify? Right? This is the email address in that code chunk file, and it might be different than this one here. So follow whatever email address is in the file that you've been provided for the course. Okay. Does everything look good? And if it looks good, you're going to say yes. Okay. And now if you look carefully, it took us back to the table of contents, if you will. But if we scroll back up in the console window here, and I want you to make sure you read this carefully. It says, I just tried to create a new email with the following info. Okay, here's who it was to, here's the subject. Okay. So if it didn't work, you can send the same email manually. So what my computer tried to do is it just tried to open Microsoft Outlook and send that email automatically. And I prevented that from happening here. Okay, if that happens to you, then I just want you to go into your email account. You're going to send it manually, putting the same exact subject information in there. Okay, you're going to send it to the same email address, and I want you to send it from your school email address. Okay. In the body of the email, what you have to submit is the following. I want you to take all of the work from that lesson from start to finish. You're going to copy that, you're going to paste it into the bottom of the email, and then you're going to send that email. Okay? That's only if it hits that problem. It says, oh, we couldn't send the email, you're going to have to do it manually. If that happens, tries to open Outlook or something and makes you send the email manually, that's okay. But you need to put in the body of the email this work from running through the module. So I said this lesson starts here. Let's say module 1 starts here. And the other important thing to do at the end of this is to make sure you save your work. So I could save that, find the appropriate place, go ahead and save it, name it, module 1, and just I'll save it on my desktop here for the moment. And that's just the name of this file if I ever need to reference that work again. You might say, well, this wasn't super important stuff to reference, but in the future, if you go through the getting and cleaning data, it's going to show you all these different ways to import different types of data files. That may be useful things to keep track of. So again, I can save that there. Now, if I need to reopen it, I can reopen it and look at all my work here. But at that point, we've gone through the lesson. You should know exactly what you need to generate that email for your submission for that module. And you're going to do that for all of the modules in the R Programming E set of SWIRL exercises. So hopefully that was informative and clear. Have any questions, follow up with me, and good luck. See you later.